talk about our invention and launch from last year, the what we call the built to last cryptocurrency, Metronome. I think it's let's leave that door open. Let's be very welcoming. Let's you know, from the get-go, this was sort of a clean slate currency, thinking about if we took all the lessons learned from all the blockchains and all the currencies from 2009, Bitcoin's launched to today, what are some of the risks that we would adjust against? What are some of the attributes we would build into that currency? What are some of the missing features that you would want that aren't in a Bitcoin or an Ethereum or currency 3, 4, 5, 6.
So today in this session we will cover some hands-on experience with the Metronome API, some smart contract function calling, and we will do the Metronome wallet interface function calling by terminal, and we will also cover what is the portability features of the Metronome, and we will do the demo on the chain hop, and after that we will go quickly about the validators.
So what makes a foundational cryptocurrency? What makes a currency that is built to last? And so obviously there's the store of value component, and how do you make sure that it maintains its integrity across a lot of events like chain forks or double spend attacks, 51% attacks. There's a lot of these events that we've seen throughout the years. MET is a cryptocurrency that uses blockchains purely as a what we call a security rail. It uses the Ethereum Classic, the Bitcoin blockchains, not for their native token, but purely as a incredibly strong security service. So Metronome is a token that you can pick up from the Ethereum blockchain and move over to and we'll be demonstrating this in a little while, the Ethereum Classic blockchain. And later on, we'll demonstrate in the coming months Rootstock, which is built on Bitcoin. So we use Bitcoin security to secure Metronome, and chain 4, 5, 6, 7, 8. Ultimately, what we're doing is we're demonstrating that a blockchain is this security warehouse for these tokens. Similarly, for payments, you have a number of features which are very interesting. You have mass pay, you have the subscription feature, which is really unique to cryptocurrencies in general. We're very familiar with this in the credit card industry, but from a blockchain perspective, subscriptions are actually very, very hard to do, because blockchains are a push payment, in that you sign a transaction, you send the payment out. Typically, a credit card transaction is a pull or a periodic payment. And so Metronome flips that script and adds subscription material and capabilities to the blockchain and cryptocurrency ecosystem. Finally, machine-to-machine. Like all blockchain tokens, this is programmable, but we have included a large number of very unique APIs to make this self-governing, reliable, portable, and that's what we'll be talking about in this talk, and ultimately fairness. So what does the Metronome architecture look like? We have, and we're going to be describing here, a chain hop feature. That's the feature that really proves out the Metronome story of, yes, it is the only token that can survive the death of a blockchain. And chain hop is that feature that lets you move away from risk to risk adjust to another security warehouse or blockchain. And this is a very key point that's also many people miss, it's not a swap. It's not a network for swapping between tokens. Because what happens when you do a swap, there is a tax event. When you go from Bitcoin to Litecoin, Bitcoin to Ethereum, You sold Bitcoin, and in most tax jurisdictions, you have a taxable cost basis that you just locked in with that transaction. With Metronome, you are moving the asset itself, like picking up a gold bar and moving the gold bar from one warehouse to another. Metronome, you are moving your Metronome tokens from one blockchain to another. That was not a sale, that was not a swap. And so therefore, unlike atomic swaps or atomic exchanges, that involves two currencies, and that creates taxable liability for anyone who's holding it. Metronome is both optimized for technical reliability and resiliency. Metronome can hop from one chain to another for governance reasons, but what's very, very consequential on the economic side is what does not happen. And that is, you're not going from one asset to another, therefore there's no taxable event. And so Metronome is far cheaper to hold and store value, because anytime you move from one warehouse to another, you buy, sell, you chain hop, no taxable events. You're just moving your assets to a new location. And this is the architecture behind that. So
this has some set of contracts which include the Metronome auction contract, proceeds, and autonomous converter. So auction is, the Metronome auction contract provide some functionality where 2,880 metronomes are minted daily, and user can buy from the descending price auction. The proceeds is all the proceeds that the received from the Metronome auctions I store into proceeds, and these proceeds help to actually liquidate the autonomous converter. So this source code, so this is the open source code. It is at this URL, and this is strongly audited by some good auditors, and then it has the Metronome smart contract source code and the wallet. These were audited by 4 external auditors, including Zeppelin and Deloitte. These 4 set of contracts include ERC20, the saving baskets, and autonomous converters. Upcoming smart contracts are the validators and token porter.
Yeah, so just to, I apologize for interrupting, Manoj. I just get so excited about certain features of it. The last bullet point I definitely want to emphasize is when you have an auction, new tokens are minted, this goes not into my back pocket. This goes into a smart contract locked away from any human access. And that smart contract sends 25 basis points from that savings basket into a DEX. It essentially buys a little bit of Metronome on the open market at market prices. Now, why do you do that? It creates this, I won't say it's a price floor, but it creates a volatility dampening effect, which we saw very successful throughout the crypto winter. When, yes, we launched, in a bout of not so great timing, we launched Metronome deep in the heart of crypto winter. But what we saw economically is when tokens were on a downward curve, this volatility dampening both reduced the volatility and it also served as a price cushion. So long story short, I observed that it fell less than other crypto tokens during the crypto winter. And it's because of that liquidity injection, a kind of a community fund for itself, locked in smart contract, that we estimate this fund is going to slowly deplete over the course of 3 to 4 years. Now that depends on market price and a lot of other variables, but it's kind of like a slowly deflating balloon that injects liquidity into Metronome in the early days of the Metronome system. And so we observed, again, with a lot of deep thinking on the history of lessons learned, a lot of these tokens, when you launch, they kind of need a centralized to decentralized flight path. And that's very critical, as you need some support in the early days, just like a young child, but eventually that child needs to leave the nest and be decentralized, otherwise we've failed. And so that key piece of economics was baked into some of the code that we're going to demonstrate here. So Manoj is going to take you through installing some of the wallets that we've given out in the little paper slips into the audience. And for those of you with a laptop and command line, you can follow along.
Yep, sure. So just want to add few points about what we call it's a saving basket. So in June 2018 we launched the Metronome. So all the proceeds that received in the initial auction, they all stay in the Metronome ecosystems. Nothing is going out. And this approximate, I think 24,000 ethers were into the proceed contracts, and that is on the daily basis 0.25% is going to the autonomous converters. So as say that it is kind of slowly maintaining the liquidity in the autonomous converter. So this is how this autonomous converter is formulated in such a way that it has the liquidity of Metronome and the native currency, and so based on these contents is decide the exchange price. So we'll have the one quick demo about this one as well. So I think you have this piece of paper with you. It's paper wallet. It has the 2 QR code. If you want to hands-on with me in this session, so you can clone this source code from the GitHub open source repository. So this is the URL, and once you clone, then you just need to run the npm i, which will install all the dependencies of this package. So this is a small 50 to 100 lines of mini project that we just created for demoing the Metronome's smart contract APIs. And if you want to use your wallet, paper wallet, you just set this the mnemonic phrase into environment variable, and then hard code into the source code.
So this is how a quick introduction onto auctions. This is, if you want to call it mining, this is kind of mining of a sort. It's minting. There is a small daily mintage. In the on day 0, there was 10 million tokens that were live, and every day 2880 or 2 per minute are minted and sold at auction at market prices. So a smart contract makes these available, and a daily auction, which is a descending price auction, auctions off the tokens. How does a descending price auction work? It's like, but not the same as, a reverse Dutch auction. You start at a too high price, far above market price, and then the price ticks down every 60 seconds until you hit an actual equilibrium price where market buyers are willing to buy tokens. And it's not the auction is not all one price for all the tokens. It is a real-time auction. Tokens are sold at price X for however many tokens buyers want to buy, and the auction ends, the price stops ticking down when all 2880 are sold. That's a descending price auction. And the funds generated in that auction, they go to this, they're locked in a savings basket, a proceeds contract. And then, again, 25 basis points of the total balance of that proceeds contract, all the ETH that's sitting there locked up, 0.25% of that goes to the autonomous converter, which we'll talk about in a minute.
Yep. So we'll go through some, how do we, after you have installed this one, then you can call some metronome functions. For example, if you want to participate into the daily auctions. So for this demonstration purpose, once you install this one, you can call, so for testing purpose, you can call info, and then it will display the auctions metadata. So what is the current minting, and what is the last purchase price, and the next auction start date, and similarly. because this for the today's auction, all the Metronome has been sold out. So this minting is showing 0. So we will not be able to buy from the from the today's auction. So this function has the payable function where so when we send the ether to the contract, it triggers the payable function, and when these payable functions actually execute this set of instructions, and it has certain logics to calculate the descending price at the current tick, and then it also consider the various logic to find the refund, allocate token, and then also close the previous auctions, because in the smart contracts the things are executed only when some accounts call the, some function. So it close the previous auctions, will forward the fund to the proceeds, and then it issue the token to the user. And we have the wallet interface, so the Metronome multi-platform wallet, which has all these features as well. So if you install it, either you can participate, so you can use auctions or the converter from the wallet, or you can use it from the terminal. If you want to develop your own DApp, or you want to write your own script to leverage the difference in the price of the auctions, or the difference in the price in the autonomous converter and the external exchange. Obviously, you can write your own AI logic to leverage and see the difference and participate into these auctions and converter.
Yeah, that's exactly right. And I definitely love to highlight the Metronome wallet. It is, again, like the smart contracts itself, and unlike many other tokens, unlike many other projects, this is audited by industry professionals both inside and outside the crypto industry, pin tested. It's available in the iOS Apple App Store, Google Play Store, and also download desktop for Mac, Windows, Linux, etc. And this provides an excellent direct interface to all of the Metronome features. You can participate in the auction, as Manoj just mentioned, and we're looking at an auction screen here. This will give you the time remaining in the auction, or if the auction is already closed, the time that you have to wait until the next auction open. There's, as mentioned, one every 24 hours. And similarly, just to highlight what Manoj was describing, the converter, another name for that is a DEX, a decentralized on-chain exchange, and there are some arbitrage opportunities between external exchanges and the autonomous converter here, whereby you can, look at how the price balances across, say 3 external exchanges and the autonomous converter. Trivia, this is the Bancor algorithm, so if anyone is familiar with how Bancor works, this is essentially a simplification of Bancor without the extra token involved. It's just a MET to native token single pair. So the autonomous converter, you exchange MET with a native currency. Why do we call it native currency? Is that Metronome is multi-chain, and we have one of these on each blockchain. So right now, Metronome is on the ETH blockchain, and the autonomous converter has a MET ETH pair. If the next chain hop target, which we'll be talking about, is Ethereum Classic, and so on Ethereum Classic, similarly, you'll have an Etsy MET pair. And on each chain, all those auction proceeds, they go into that savings basket, that proceeds contract, that goes into the native currency side of the trading pair. What does that mean? What does that do? Is that creates an incentive to deposit Metronome into this DEX, essentially buying a little bit of MET on the open market at market prices every day. That's how the volatility dampening actually works, is this liquidity injection into the market on a daily basis. So again, all of the token sale proceeds, the auction proceeds, they don't go to people. They don't go to a team to build, X, Y, and Z. Those proceeds are locked and managed by a smart contract exclusively. We don't have access, even in an emergency, to those funds. And that's a very important point from a governance perspective. It's locked away and algorithmically controlled. So that's the autonomous converter. That is present on each one of the chains that Metronome supports, so that you have a native token, whether it's ETH, Etsy, Rootstock on Bitcoin, Quantum, EOS. Any of these will have a native token to Metronome converter. That really helps the ultimate project goal of this is a single global currency across all these blockchains.
So I will go through this source code, that how can we call these autonomous converters functions from this mini project that we created. So this project has a couple of functions that is purely the return for today's demo purpose. So here you have the wallet.js. If you want to call this one, so we have 4 functions to demonstrate for the conversion. One is for convert Metronome to ETH. So this convert that is the Metronome currency to the native currency. So we are demoing on the Ethereum. So it will in exchange it will give you Ethereum from the converter. So let's quickly call this one. I will just demo this one. So a standard way of calling some node functions is just, so this is standard command where invoking a function from the wallet.js file, and then these functions take 2 arguments, which the input that how much the metronome you want to send into a converter, and the second argument is the minimum return. So if you call the estimate function, you can see that what is the expected return for this input, and then in between when you are sending the transaction, someone else sends some transaction, then it will change the liquidity contents of the autonomous converter and the price can change. So you can mention, so what is the minimum return that you are expecting.
And I would definitely advise to use that feature. That's an important safety feature.
So this one actually calling into mainnet Ethereum, where the fonts may be small. I think maybe not visible from the back row. So it will give the approving to the Metronome ERC20 contract, and then after that it will transfer. The autonomous converter will pull this Metronome token from your account and then from this address, and then this autonomous converter will actually apply the Banco formula, and then it will return the exchange amount in the native currency. So functioning of the autonomous converter is like it generates the intermediate smart tokens, which is actually helping us to implement the complex the conversion algorithm, because the formula is having this kind of square root. So and then 2 or 3 stages where we use intermediary smart token to generate it, and also we have to take care about the gas efficiency. So applying these kind of formulas with having the kind of the multiplication square roots where the Solidity do not provide the square root, still we implement the square root based on the mean divisions algorithm, and still it is the gas efficient formula. So in the background it generates the intermediate smart tokens, and then it burns it again, and then it actually gives you the exchange cryptocurrency. It may be either the Metronome or ETC, Ethereum, or the Quantum, whatever the underlying chain is. So this has certain smart contract functions. So when we convert, it actually call this the redemptions and the minting of this smart token. So I will go through this one again with the. So we just did one demo of converting the Metronome to the ETH. I will do the similarly. I will send some ETH to the autonomous converter, and we'll see the return. I'm sending 100,000 V. So at the same time, when you are playing with the autonomous converter, you are sending the Metronome. After 30 seconds, you send the ETH. So obviously, so there will be some price difference, because the one contents is increasing and the other liquidity is the decreasing. So you can see, because we just sent the Metronome, and after that we just sold the Metronome again. So the price that we'll get in the autonomous converter will be different, because of the one liquidity, two liquidities are changing at the same time.
Yeah, it's an active market just like other DEXs, and so you'd expect to get that market price at that particular instant when you convert MET to ETH or ETH to MET.
Yep. And this is the Metronome wallet interface. So you can use this the wallet interface to convert the ETH and MET. And then it has, after we actually initiate the conversion, it will show the estimated conversions, the return in the next screen. And then once, you can specify the minimum return as well.
So these are an example of some of the additional features that we have that you can call as part of the Metronome API, since this is definitely a coder and code focused demo. First one is very unique and very cost conscious, I guess, for Ethereum users and other chains, Etsy users, et cetera, mass payment. Unlike Bitcoin and the Bitcoin cousins such as Zcash, Ethereum is just a one-to-one payment. If I want to pay 10 people, I have to create 10 transactions, and I have to pay 10 times the transaction fee to pay 10 people. In Bitcoin, which is sort of my roots, you can pay 1 to 1,000. You can pay 1 to many. And I said, why does ETH not have this? So we added it. Mass payment is a one-to-many payment that saves you quite a bit of transaction fee, because you create one transaction to pay 10 people, or one transaction to pay 25 people. So it's far more efficient to the network, and it's also economically less in terms of transaction fees. Subscriptions are another thing that's unique to blockchain projects, in that normally you initiate a payment and it goes out to folks. That's the basic format that all blockchains very natively support. Subscriptions are radically different. That's a periodic payment that's a pull payment. But blockchain and cryptocurrencies tokens, they were intentionally designed so that some third party cannot just go and yank your money. That's a really fundamental part of the system. So how do you resolve this paradox? How do you resolve this conflict? And we added very specific subscription features to Metronome. Again, as far as we're aware, this is unique to the ETH ERC20 ecosystem, is you set up a set of periodic payments that are approvals, and then anyone, since the approval was already approved by the payer, anyone in the world, Bloq, or a volunteer, or the subscriber, or the subscribee, can release that payment, move that payment. And so within the context of the ecosystem, we have just a robotic service that can go out there and call out and initiate payments on behalf of anyone, and we're not custodying any money, we're not in the money flow chain. We just have this machinery that issues payments on a periodic basis. So I think it's a very, very interesting and unique feature that it had to be form fit for how blockchains work, and so it's the user experience is a little bit different from your credit card subscription payments of I authorize $10 a month from Netflix, but it's getting very, very close to that. And with a little bit of wallet client-side modification, we'll actually get there in terms of user experience. So that's one of the features that excites me the most, is bringing these very familiar form factors, payment factors, from outside the crypto world and making them work in a way that makes sense in the crypto world.
So in mass payment, we actually this has the important benefit as well, that instead of doing the end transactions, the assumption is that for the end transactions, some certain amount of gas that would be consumed. If you go for the mass payment, it will save. We have tested it for some numbers, and we see that the actual gas consumed into mass payment call is somewhere between 30 to 40% less than what you call if you execute the end transaction n times. So these are the. I just want to show the last.
That's a tweetable number right there.
Yep. So so we funded the 50 paper wallet with the mass transfer, and so this is the mainnet transactions there. So you can see the mass transfer into action. So these are so we forwarded 3 Metronome to more than approximate 50 wallet, and then it does execute, and actual gas consumed is significantly good number.
Yep, we use that feature to prepare this demo today.
Yep.
Now finally, and the thing that I am excited to talk about today is portability. And this is a big part of the Metronome story, and a big part of the governance story of Metronome itself. Is that, again, we built this to be an autonomous currency. What does that mean? That means that it's not controlled by anyone, even the authors. And a key part of that self-governance is that you, the Metronome holder, can vote with your wallet where that metronome, what blockchain it should be on to secure your assets. And so that gives you freedom of choice. That gives you the ability to seek out what is the strongest chain, what is the least cost chain in terms of transaction fees, what is the best chain in terms of settlement. So there's a huge amount of choice that's available within the Metronome ecosystem to Metronome owners. It's a store of value in that MET is still MET, no matter what chain it's on, getting back to that key tax observation. And how does it work internally is there's something called proof of burn. So, you know, it maybe is a little, the B word is a little bit scary, but what it is a guaranteed proof that your metronome can exist on one and only one chain. This is a synchronized, functions as a synchronized metronome tick, like a clock tick, across all of the chains where Metronome lives. This creates this constant global supply where one chain, even through a hard fork, is not going to inflate the Metronome supply. So validators, and we'll talk about those in a minute, are the ones that are the assistants for when Metronome goes from one chain to another. You have to validate that receipt, that Merkle receipt, that proof of burn that says, I moved my Metronome from one chain and I'm putting it on another chain. And so that's a bit of both high level and low level, is why portability is that you want to have that freedom of choice, you want to have that self-governance, and that self-governance is the reason why we feel that Metronome is the most resilient currency, is regardless of whether it's a, if Bitcoin lasts forever, or if ETH lasts forever, or Etsy, pick your chain, Metronome can function on that security rail. But if one of those has a problem, you can risk adjust away from it. So it's not a network for swapping other coins. This is a new novel way to make Metronome the token that is the currency that lasts for 100+ years.
So this is the high-level technical architecture about how the portability work in the Metronome. So when the user want to do the chain off from the one chain to other chain, they generate the export receipt, that is the proof of burn, and submit that receipt to the destination chain. And then some on-chain validation will be done. At the same time, the network of validators will keep watching this chain, and they will do that this specific transaction exists in the source chain at the specific block. So two combinations. One is the on-chain validation, where the Metronome smart contracts know that what should be the current global supply across all the chains. So it will do those kind of validations, and after that, the validators will do their jobs to validating. So once all these validators have the consensus, then they will stamp it, and then they will the minting will happen on the destination chain. So on-chain validations will have certain parameters like the destination's chain address, the validator, and some the global supply, current daily minting on the all chain, and then this will have the synchronized tick of the Metronome across all the chains. So we will do
Question.
We have time for any questions at all.
Yeah, please
Yeah, sure.
interrupt, absolutely. I come from the Linux community where you just stand up and ask a question.
So when you're validating the Merkle proofs, do you just check one block? Don't you need additional confirmations? I mean, the chain can get read.
Oh, absolutely, it's very slow, and so the import-export waits a number of confirmations, and so it's like a 12 to 24-hour export-import process for that reason. So absolutely, it's not just one block or two.
Okay, and the other question I had is that what happens if Bitcoin forks into Bitcoin Cash, and now you have two Metronome tokens that are running in parallel equally? How does that not inflate the supply of Metronome?
The validators serve as a which fork you choose point.
Could you
So-
expand a little bit more on that?
Sure. So, leave that validator screen up. And so the validators are the ones that sit in between chains, and we have 3 phases of validator development. The first phase is basically a federated network, just like everyone else is doing. So you have 5 people who are, independent legal entities like Bloq and BitPay and XYZ, and they each run the same protocol, similar to, like a Factom federated network or a Blockstream Liquid, or pick your other federated network. And if all of those, vote 17 out of 30 or whatever, that this is a valid chain tip and burn, then it gets validated. So what happens in a Bitcoin Cash fork is those validators are the ones who are saying this is the real Bitcoin. And so again, it's not us making a choice, it's this validator network making a choice. And yes, the federated network is a bit centralized, and so that's a centralized decision. In phase 2 of the validator network, you get to chain-specific tip validators, and specifically, validators stop validating Metronome transactions and completely remove themselves from that governance perspective, and we just look at a group of ETH validators that attest to this is the real ETH. and a group of Bitcoin validators that attest to this is the real Bitcoin. And so it's literally, the phase 2, not specific to Metronome at all. You just have essentially a group that's saying this is, the fork to pick in the Bitcoin side. This is the fork to pick on the Ethereum side. So we remove us and our validators out of that pick which fork the community chose decision.
Thank you.
But in terms of Metronome, it's programmed to, you only follow one fork. And so the other fork that is sort of the branch not chosen, that is just ignored and can't be Merkle validated by the Metronome global supply. So when you have twins, you got to pick one. Any other questions?
How many validators you have? That's centralized.
Yeah. In phase 1. In phase 1 is centralized. It's a minimum of 5. We're shooting for 7 to 15 for our T plus 30-day initial release. But we want to grow that network. And we've been looking at some other, and this is totally sort of unbaked inside baseball type stuff, but we've been looking at sort of Echo Algorand type random validator selection for consensus methods type of system for larger numbers of validators. Because you've got, obviously, in the blockchain ecosystem, in terms of finding consensus, you've got proof of work, the original, you've got proof of stake, you've got proof of space-time, and now you're starting to see some of these Byzantine fault-tolerant third-generation consensus algorithms. And when you have a large number of validators, that's actually what we want to use. So it's bleeding edge science. The simple answer to your question, if you want to pin it down on a number, is like 5 to 7 on the initial release. But we're absolutely not happy with that answer at the same time. And we want to have that flight path to decentralization. That's key to the governance story.
Yep.
So good question.
Yep. And to maintain the healthy ecosystems in the validators network, we maintain the reputations of the validators. So we do have, each validators will, in the vision that we have something like the validators will have their credits, the earning the points based on, how many attestation or the validation they are doing, their specific node is properly synced or something. So even if in the network of 5 or 15, somewhere 1 or 2 bad actors will not impact our the validator network as well.
Yeah, there's reputation and monitoring, et cetera.
Hi, actually, I had one question. We missed the first half, so maybe first 10 minutes. So the question was, so why would I change my, my wallet, my MET tokens from ETH to maybe Bitcoin if the pledging is on the MET value will be a market value, right? So why would I ever move those coins around?
So I use the analogy with gold bars in a security warehouse. Is we use the blockchain purely to secure the Metronome system, the Metronome token. So why would you want to move it from one blockchain to another? One real-world example is that different chains have different transaction fees. And so Bitcoin and Ethereum, they have a higher transaction fee level than ETH Classic. And so if you're doing a lot of Metronome transactions, what might be smart is move your MET from a high security Bitcoin ETH chain to maybe a little bit lower security but cheaper Etsy chain, do a lot of transactions, pay very low fees, and then move back to the high security chain. So that's one real world use case. The not very often used but important use case is what if one chain is going to die? What if there are some serious problems coming down the road? You can risk adjust away from that chain, and 1,000 MET is still 1,000 MET. Just like when you pick up a gold bar and move it from one warehouse to another warehouse, you still have one gold bar. And there were no taxable events. And so similarly, when you move MET from one blockchain to another, it's still MET. It still has the same value as it did before. It's just maybe quicker settlement time, lower transaction fees, avoiding a chain disaster or a chain drama or something like that. So it really gives a lot of optionality to how and where you're securing that part of the MET.
Yep. One more important use case about the chain op is that in near future, if some chain has the very good layer 2 solutions for like state channel or the lightning net or something where, or you may want to utilize some chain which has the no gas fees, just staking. So you just move the MET there, do your transactions, move back. If you want to trust some chain more for the storing the value, keep it there. If you want to utilize some chain just for the state channel or the layer 2 kind of solution, move there, do the transaction and store it into some other chain. So that's one important use.
And one other point about the validator network to complete the picture. Again, very central to Bloq is having that centralized to decentralized flight path, where the ultimate end state is there is no validators at all that are special parties on the network. So phase 1, we have this federated validator type network. Phase 2, we have individual chain validators which attest to tips, and those are the pick a fork, essentially, validation step. Phase 3 is what we call blockchain of blockchains. And so similar to, and this gets a bit technically complex, but similar to how Bitcoin itself functions, you might have 10 nodes on the Bitcoin network. The way blockchain works, every single one of those nodes has a 100% copy of the blockchain, a 100% copy of the ledger. It's not partitioned, it's not sharded. Every one of those 10 nodes has a complete copy. So we're similar in design. Phase 3 of the Metronome cross-chain feature is that we actually have a blockchain stored in a smart contract and communicated between chains. We call them lily pads, this cluster of smart contracts on one blockchain, say ETH, communicates with another lily pad on another blockchain, say Ethereum Classic. But what it's actually doing, the original from 10 years ago Bitcoin algorithm, it's sharing the transactions that move not from address to address, but from chain to chain across all of the chains that support Metronome. Just like Bitcoin broadcast transactions, we broadcast chain hop transactions to Metronome lily pads. So validator version 3 is no validator at all. So that's a key observation about this centralized to decentralized flight path, is the validator network that we're about to debut is something that we plan to eliminate.
Yep. So we'll go through
He has
one
a question, so he's been waiting patiently.
Sure.
Yeah, so when I receive Bitcoin, a Bitcoin transaction to my address, I will own that Bitcoin as long as the integrity of the Bitcoin chain is intact. With Metronome, if I receive a Metronome token in your final state lilypad view, are there any extra trust assumptions that comes with owning that Metronome? Perhaps there's some SPV security style trust assumptions, or do I need to trust any extra assumptions in order to keep those coins?
Not as far as we're aware. It functions basically like an ERC-20 on the local chain. And when you transfer from address to address, it's exactly like an ERC-20. So all of the assumptions that come with a ERC-20 token on, say, ETH, you'll get the exact same experience. And it's just when you move MET from one lily pad to another, that's where in stage 1 you have to trust the validator network, which we're going to eliminate. In stage 3, you have to trust, just like Bitcoin itself, that the algorithm works.
So you're saying that the chain tip selection in your end state is going to be basically completely trustless.
That's right.
Okay, fascinating, thank you.
And so it's stake weighted per lily pad. And so if you create Adam's crazy Ethereum fork, and there's only like 2 users on that, that has a very, very low stake weight versus existing lily pads. And so you have the trust metric based on how many people are on each lily pad in phase 3.
Yep.
So
we have
we
5
want to, we got about 10 more minutes. Since we've been taking questions throughout, what we're going to do is get to demoing our cross-chain port, which is the key thing we wanted to demo. So take it away, Manoj.
Yep. So for the chain hop, so we can either use the Metronome wallet or call the API from the terminal. So we'll go. So this is currently, this wallet is connected to 2 chain, the Ropsten, which is the Ethereum testnet, and the Modern, which is the Ethereum Classic testnet. So I will do some the Metronome movement from the Ropsten to the ETC.
And this is also a preview of the wallet with the porting mechanism that Manoj is demoing right now.
So this will initiate 2 transactions. That is, it will actually burn the Metronome from the source chain and will submit the export receipt on the destination chain. This user will pay the gas fee for these 2 transactions, and the validator's fee will be deducted, additional need to pay by the users, and this fee actually distributed as an incentive to the validators. So while we are waiting for these transactions, I will just go through that how the export functionality looks like. So export has the certain parameters. So these are the 10 to 12 parameters that we actually save it on the blockchain as a export receipt, and which it also has the sequential export hash, which is cryptographical hash of all these the parameters, and it is sequential, so that all the exports can be tracked sequentially, and we also generate the similar the import hash on the destination chain. And so that whenever the validators are submitting these informations during the validations, this data can be validated. So I have one instance of validator running at my computer. So this will watching this 2 chain, and will currently I have set the block height 1 just for the demo purpose. But ideally, to avoid the soft force issue or the ad hoc chain log issue, we wait for certain heights as like 4,000 to 3,000, somewhere between 4,000 to 5,000 block height, maybe equivalent to 24 hours of time.
So I think in the interest of time, we'll just summarize, because it is a live demo and we're executing it on the network here. But to summarize, the wallet integrates this. Can you go back to the wallet screen for a second? Yeah, it integrates the porting function. And as mentioned, I think for your average users, what are the use cases is primarily not normal users. I think most users will stick to one chain most of the time, absent emergencies and disaster recovery. I think traders will definitely use the porting function quite a lot. I think that if you have some automated systems, you'll use porting to optimize for, say, lower fees if you're doing a lot of MET transactions, and then move over to sort of the Bitcoin, Ethereum world for a higher security rail. Over and above that, let's go back to the presentation.
Yep.
Yeah. So keep going.
Back.
Yeah. Just, no, forward. So yeah, the validator setup, and we're inviting external community folks to be validators as well, is very, very straightforward. It's moderate hardware. The biggest requirement is a Geth node, which, you know, a little bit of self-interest. We also, on the Bloq side, we offer a node service. But if you're technically inclined, it's just a Docker container and the Met validator image inside. So even for technical folks, it is really just a download and go. So thank you for checking out the preview of Metronome and our chain hop porting solution. We have like 120 seconds if there are any final questions. So anyone, I think we pretty much answered a lot of the questions during the demo, but any closing thoughts? All right, well, thanks everyone for coming. We're really excited to release the porting feature.
Thanks, everyone.